in trouble when y'all have like for real jobs and you like actually have to be on time. They
It's
start
still
docking
two
points.
15, so calm down.
I show up to my work late all the time.
I said a real job.
Thank you for
I
being
said a real job.
Oh, whoa.
$12 an hour, that's really tough.
No, honey, that's not.
I make $5.
For an
I'm so
18-year-old, that's
sorry.
really tough.
I'm so sorry to hurt your feelings.
Not hard though,
All right, we're gonna go over our review. I'm gonna drop down.
So the adults that work, like things work?
Do what?
That's a real job for them?
What?
The adults that work at Ben's work? You don't think that's a-
No, I'm more mature than them.
Did you have a job like that as a teenager? You don't have any like.
You learn how mature you actually are when you're real
You'll
quick.
walk in and be like, "What are you?" Like, yeah, no, like, that's how you do it. Yeah, I know.
Okay, we're gonna keep going. We'll continue this conversation later. Shh, 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 shh. All right, school officials are interested in implementing a new policy.
You don't work out?
What?
You don't really work out?
No,
So you might have to do it for nothing?
sure.
You actually did it?
Huh?
You actually did it?
He always does his work. He just doesn't do it in class. Mhm.
Just 2 days late.
Hey. Okay, I have 10 cheerleaders and I'm coming right off the football field, so I'll be there as soon as I can. I have eight cheerleaders. Yeah, Shallow and them will be coming with me, so just don't leave me. All right. Already, stuff already. What? Stop throwing. All right. I'm not gonna read all this. Describe the shape, center, and spread of the sampling distribution. So how do I figure out the shape?
The main one.
Yeah, so what did I do?
The large.
Right. But what are my numbers?
Oh.
How'd you get 125? Okay, 125. Uh-huh. What'd you get for that? So 75. Okay, what up? Is that it? We're good? Okay. 160 times gave me, say it again. Okay. Okay, what about all this? Sorry, let me close this a little bit. All right, so that's your shape. What's your center? Which? So what'd you get? 0.15. So your that's your center. And then standard deviation, you should do the 10% rule. I'm not going to do that, but what'd you get for your standard deviation? Everybody get that? 5, yeah, it's 556 in the book. Is everybody okay? Any questions about the standard deviation rule? What is that formula for standard deviation? This big fat nasty rule up here. Is everybody good? So that's where it came from, putting those proportions in, and then your N1, 125, and your N2, 160. Everybody good? All right. Oh, sorry. Find the probability of getting a difference in sample proportions of 0.07 or less from the two surveys and show your work. So the probability is going to be your p-value. Got it? So we found our p-value. Good gracious. All right, z equals Where did this 0.7 come from? 0.07.
That's for statistic based.
Okay. 0.07 minus your actual mean is 0.15. On the bottom, your formula. Doesn't matter which one you start with, 0.25, 0.75, and that sample size was 160. Or 0.6 times 0.4, and that sample size was 120. And that gives you a negative 1.439. And then it said that value or less. So you want the probability that Z is less than negative 1.439. Put it into your normal CDF. Everybody got that? And what did we get? Perfect. That's it. Everybody okay? All right. Does the result in part B give you reason to doubt the study's reported value, and explain? No, what? Tell me in a statement.
Wouldn't that be like, you've been doing it through the alpha. I mean,
Okay. So on this one, and you don't really have one like this on your test, and I know that's because I just typed up your test last period. So really what you need to know is how to interpret the p-value for your test, okay? So this one, the answer that they give in the book is assuming the stated proportions for each high school are true, there is a 7.5% chance we'd observe differences. So 7.5% chance of observing a difference. Between the sample proportions at least as extreme as those observed. This says we do not have evidence to doubt the study's sample proportions. So we cannot doubt. Hold on. Right here, there's just a little tiny chance of observing the difference. So right here, find the probability of getting a difference in the sample proportions of 7 or less. So let's look. Let me try to make it where I can think about it. If we had this p-value and compared it against alpha, what would we have? Which means what? Well, we've used 0.05. What would it mean? What if we used 0.05? We would fail to reject each sub O. So that means we can't doubt them. We can't say that there's not a difference. Does that make sense? So that's what that's based on. It's just the alpha level. So this is your same conclusion that you always do. All right. So that's your first one. Your second one, again, uses that formula because it wants you to construct a 95% confidence interval and interpret. Please do not forget that on your test. Okay, don't forget that. So a couple tests ago when we were doing confidence intervals, a lot of you forgot to interpret. And by a lot, I mean 2 or 3, which is a lot to me since we do it every single time in the conclude part. Okay. So in 1990, 551 of 1,500 randomly sampled adults indicated they smoked. In 2010, 652 of 2,000 randomly sampled adults indicated they smoked. Use this information to construct and interpret a 95% confidence interval for the difference in the proportion of adults who smoke in 1990 and 2010. So the formula is up here. What should we do? Before we construct, what should we do? Yeah, we can do our state plan, do, conclude. In our state, what are we gonna put? All right, let me make sure you're doing on the same line. What's your proportion for 2010? $652 over 2,000 is 0.326. What's your proportion for 1990? 0.467. 367. I was gonna say, I thought that looked weird in the book. All right. So y'all, instead of kind of mixing it up, I like to do it like this. So the proportion in 2010 is the true proportion, blah, 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 in 2010, instead of labeling it P1 and P2. You can label it P1, P2. There's nothing wrong with that. All right. And then the other P hat, 1990, is the true proportion in 1990. Is that all that goes in the state? Mhm. Plan. To sample Z interval for a difference of proportions. You got to test it. Is it random? Yes, it's stated. 10%. Say it again. 10 times what? And so that would be 15,000 and 20,000 adults in the US. We know that's less than 10% or right at 10% of the population. It'll be less than. And then the last thing. Large count. Mm-hmm. What's your success? So your failures would be? Say it again. Uh-huh. And then the other one? And? All greater than or equal to? So yeah, anytime you're dealing with proportions, your successes and failures will be exactly what you come up with. All right, state plan due. That's your formula you're going to put in up here. Remember, you don't have to do a lot of work with that formula if you want to do it in your calculator, but I would suggest that you write the formula down, okay, and then define everything. And so in my formula, instead of doing P hat 1 minus P hat 2, I'm doing P hat of which one? 1990 minus P hat of 2010 plus or minus Z star big fat square root P hat 1990 1 minus P hat 1990. And again, it doesn't matter what order you put these two in. Your N of 1990 plus P hat of 2010 1 minus P hat of 2010 over whatever your N of 2010 is. What would your Z star be? Good. So somewhere on the paper, and again, even if this was your test paper, because I defined P hats up here, they'll still count it. Okay. It doesn't matter where it's at on your paper, they grade everything. All right. So then when I put those values in, I should get 0094 to 0.0732. What does that mean? We are 95% confident.
That interval captures the true difference in the proportion of adults who smoke or who reported that they smoke in that
Captures the what?
true difference in the
Good.
proportion of adults who indicate they smoke.
And proportion. You need to make sure that you have this true difference in proportion. If it's the other one, the true difference in means. Okay. In context of the problem, and the proportion of adults who smoke in 1990 and 2010. When we get positive numbers like this, what does it mean?
That's a difference, that it was higher.
It was higher. Okay, so make sure that you state that in there as well. All right. Any questions on this one?
Wait, wouldn't you like write down that it was right, it was higher?
Yeah. Who smoked in 1990? Was higher than 2010. Everybody good? Good. All right. The next one. Do these data provide convincing evidence that the proportion of low-income students at Lakeville North is higher than the proportion at Lakeville South? Use a 5% significance level. So that means that your alpha is going to be 0.05. Again, it doesn't matter where it's at. We're going to do the state plan do conclude. What goes in your state? H sub O.
He had in,
You can use that one algebraically too, where you want them to be equal, so there's no difference. And if you write it like that, that's perfectly fine. If you write it like I showed you yesterday and you don't subtract that over, it's also okay. All right, it's the same exact thing. So what I'm saying is if you wrote this, no difference means that they are the same. They will accept that as a null hypothesis as well. That makes sense? All right. So what about your alternative?
he had in, he had.
We want north to be greater than south. So if I subtract that over, p hat n minus p hat south is greater than 0. And then I already have my alpha level over here. Define these two. Okay, and make sure that you put that in there. Any questions on the state part? Okay, that's like 4 points. 1, 2, 3, 4, 5 points. So if you're getting like minus 2 out of 13, I add up how many parts that I'm looking for. Does that make sense? So that would be the 13. And then if it's taking points off, you're missing one little part of that. All right. So I don't take off the whole thing. Plan. What are we going to do?
If it's 15, 14.
The difference in the proportion. You can just say for proportions, that's fine. All right, what do we do now? So the first one is random. Was it random? They stated that it was random. 10%. Say it again. Sorry. Okay, it doesn't say that it's bigger, but usually these are gonna be fine.
The first one, the first column was in the south. Or was that the same two schools?
Yes. Yeah. All right, what next? What are we doing next? We did random and 10%, so now large counts. If you want to just put normal, that's fine. These you can do your successes and failures as well. So we had 28 out of 120. What else would that be? Louder. I was gonna say. What's your other one? 30 and 120, which are all greater than or equal to 10. Perfect. Everybody good? So far, so good. All right. They gave you the formula. You can do this on your calculator. I don't care. It's up to you, whatever you want to do. So we're looking for our Z. And remember, our formula for that is going to be your difference minus 0. And why is it 0? Everybody good with that? All right. And then on the bottom, pretty nasty, your p hat combined, 1 minus p hat combined over n1 plus p hat combined, 1 minus p hat combined over n2. So the 3, 4, 5 things we need, all the p's and the n1 and the n2. So what is your p hat for north? How do you get that? And that is? Point 2 what? And then p hat south? Oh, sorry, I did. Say it again.
Oh, wait, no. I'm
No, no.
looking at those combined.
Nope, I was right, sorry. 30 out of 150 is what?
That gives you
0.2. P hat combined, now we're at combined, are the top two numbers, 28 and 30, add the bottom two numbers. And then what did you get for P hat combined? Which is,
I don't know.
that's okay, 0.2148, that's a 2, sorry. Now, you don't have to plug this in at all. That is good enough if you put it in your calculator to show what you plugged in. Just have your N1, what was your N1? And your N2?
You put N and S.
You can. So good, this will be NN, NS, okay. What Z value did you get?
0.6511.
You kept the fraction, I rounded. You're fine, it's gonna come out the same way. I got 6626. Did you guys get that, more of that value, or did you get more of her value? Okay. It's because you put yours didn't round, because you put the fraction in. Mine is a rounded value, so that's why. All right, and then we're gonna do the probability that Z is greater than 0.6626. Do your normal CDF and what do you get? Uh-huh, 0.2537, 254 is perfectly fine. Yours is a little bit different. It's a little bit different, not too bad. And then we conclude. So we test our p-value against our alpha. What do we know?
P-value is greater, so we fail to use it.
So what does that mean?
We do not have convincing evidence that the proportion of low income students at Lakeville Road is higher than the proportion at Lakeville.
That's exactly it.
Where's Lakeview on all this?
That's okay. Any questions? 10.1. All right. 10.2 is basically the same thing. We're just dealing with means instead of proportions. So describe the shape, center, and spread of the sampling distribution. So how do we figure out what the shape is?
If both of the n, if both sample sizes are greater than 30, then it's approximately
Okay. So what are our sample sizes?
both of the.
All right. What about our center?
It's just maybe one minus 22, so 96 minus 72 equals 24.
Say it again.
96 minus 72.
Tell me again. I'm sorry.
96.
96. That's not what I thought you said. That's why. All right. And we get what? 24. Last thing. How do you find the spread?
The square root of the standard,
Mhm.
the first standard deviation over n1 plus the second standard deviation over
What was your first standard deviation?
18.
So 18 squared over, what was your sample size? Both of them were 40, so it's not really going to matter. What was your second standard deviation?
194.
And it should give you 3.21. Any questions? Everybody okay with those? Okay. Find the probability of observing a difference in the sample means of 2 points or more from the two samples and show your work. So how do we do that? How do we do that? How did y'all do it?
You can find the t-value first, so we need to minus what, so if it's difference of 2 points or more, then it would be 22 minus 24, that's what I showed.
Where did the 22 minus 24 come from?
It's what you want versus the minus what you
What do you mean?
have. It's gonna be minus 2, right?
It's going to be the difference of the mean, right? So your 24, you're going to actually find two values because this is a two-sided test. Y'all understand that? So when you find your t, you're only going to have one. It doesn't matter which one you do. It could be either the 22 or the 26. You see what I'm saying? So this one doesn't say, it just says there's a difference and it could be either way, okay, left or right. So pick one of them. So I'm going to do 22 minus 24, which means I'm going to do the lower end over that standard deviation that I got from right here. So again, where did this 22 come from? It's 2 points away from the 24. The other value I could have used is a 26 because it would be 2 points higher. So either one is going to get you the right answer, okay? This gives you a t value. This one will give you a negative 0.62. The other one would give you a positive 0.62. All right. So then what about our p? Think about it this way. We have a two-sided. So this is going to be, sorry, this is going to be everything less than that. So our t or our z is less than negative 0.62. So when you do, what are you going to do now? What do we do here? Because I don't think we've done that in a while. We just been putting it in our calculator and doing the whole interval or the whole p-value deal. What would be your lower and your upper, and then your degrees of freedom?
I did 26, so I did the opposite way.
Okay. So what about this one?
Your lower will be negative 10.
And then your upper?
Negative
So you can see it right here. This is high as that shading goes. We want everything below it. What are our degrees of freedom? It's the same, no matter what. What's your degrees of freedom?
I put the whole thing in the calculator and it's like 58.
But what would these be?
I don't know. Is it 39?
It is 39. They're both 40. Remember, you used the least one, but this one doesn't matter because they're both 39. It will still come out the same way. So your value will be the same as my book value. TCDF, your lower is a negative 0.62. Degrees of freedom are 39. So this one would make our T value 0.62694. What'd you get for yours?
0.269.
So you're close. Everything's close. See, it doesn't hurt anything. But this is a two-sided. So we have to multiply it by 2. And we get 0.5389 or 88. It doesn't matter. This is your probability. Everybody good? All right. Concept 2. Construct and interpret a 95% confidence interval for the difference in mean weight loss for the two diets. So state, are you guys good with the state? Are you good with the plan? What's the difference in this plan? The random is going to be the same. The 10% is going to be the same. Now we're doing large sample. So I do want to go over that real fast. And how do we do large sample? What was the sample size? Were they both 100?
Yeah.
And those are both greater than or equal to what? 30. That's the difference. Okay, so this is the only thing that's different in the checking. What is this one going to be? A two sample. And why is it a t interval? Because it's for means. You can just put the t interval. It should be fine. All right. Your formula is up here if you're going to do it by hand. When you take your test, use it. Is everybody good? You have your formulas all on these sheets. That's all you need. So 2 sample t interval. We need x bar 1 minus x bar 2 plus or minus our t star square root of our standard deviation of the first sample squared over n1 and n2. All right, so what is X bar 1?
9.3,
Perfect. X bar 2,
7,
say it again, 7.4. How do we find our T star? Do what? You guys are just putting it in. It does give it to you when you just use your calculator. But how do you find it if they ask you just for your T value? What if you get a question on your test and there's not one on this test, but on your AP exam and it asks you just to find T value? And how do you do that? I'm not hearing anything that y'all are saying. Yes, you do. How do you find your Z value? Inverse norm. So how do you find, yeah, inverse T, don't forget that. So second bars, inverse T. I do my area 0.05. I just divide it by 2 so I don't have to do it in my head because I'm pretty lazy. And then why are my degrees of freedom 99? Yeah, both the samples are 100. Make sure if you're doing this, anytime the samples are different, make sure you choose the least amount of degrees of freedom. Everybody got that? Least amount, okay? And then when we paste it in, we get negative 1.98. You don't have to write the negative. That's taken care of in the formula, okay? So one is positive, one is negative. Everybody good with that? All right, so I need S1. I need S2. And then I need N1 and N2. Both of those are 100. And I think that's got us covered. Your interval 0.6827 and 3.117. And then what do we do? Conclude. Conclude what? That what? Just make sure you write the interval captures the true difference in mean weight loss for the two diets. Everybody good? Is there a difference? Say it again. Is it? Everybody good? Okay. Any questions? The book answer is wrong. It's fine. Is everybody good? All right, next one. Should be the last one, right? Yep. Do boys have better short-term memory than girls? A random sample of 200 boys and 150 girls was administered a short-term memory test. The average score for boys was 48.9 with a standard deviation of 12.96. The girls had an average score of 48.4 with a standard deviation of 11.85. Is there significant evidence that the 5% level to suggest boys have better short-term memory than girls? Higher test scores indicate better short-term memory. So just going to go through a couple things. What is your null hypothesis? And I'm going to show you this way. Boys equal to girls, or you can do boys minus girls equals 0. What's your alternative? Boys are greater than girls, or is greater than 0. Either one of these will work. You don't have to do both of them, just whichever one you're comfortable with, which makes it sound right, okay? All right, your alpha is 0.05, and we're not worried about labeling them. Don't worry about that. Let's keep moving. All right, what do we do after that? What do we do? 2 sample t-test. And we check conditions. And we've already done that in the other one, so you guys know how to check conditions. I gave you an example of that. So state plan. In the do part, we need to find our T value. And to do that, you're gonna do, sorry. And if you're looking at some answer keys, they don't include this. Why would they not include that? It doesn't do anything, right? So if you're not seeing that 0, it's just because it doesn't do anything. And then over the square root of, what do we have? What goes here? Okay. What is our x1 or x bar 1? X bar 2? S1? S2? Sorry. Say it again. N1 and N2? 200 and 150. Should give you a T value of 0.375. Everybody get that? And then how do I find our P? It's the probability that T is. And we put that in our calculator, and I already showed you how to do that, and you should get a P value of 0.354. Is everybody okay with that? What? If you do it all in your calculator, like you do it straight technology, yes, it'll give you everything. Okay, just be careful. All right. And then we're going to conclude, and what do we conclude? So 0.354 is greater than 0.05. So we fail to reject H sub O. That means we do not have convincing evidence that the result, to reject the null hypothesis, we cannot conclude that the boys have better short-term memory than girls. And that's it. Any questions? All right. So what I have for you now. Sorry. Everybody was on Zoom. I wouldn't have to do this. Is in the back of your chapter. There is an AP statistics practice test. I only want you to do the multiple choice. Got it? So chapter 10, AP is on the devil's page, 666. And just do the multiple choice. It's 10 multiple choice. Okay, I hope you guys on Zoom heard that. Page 666, just the multiple choice of that test review. Okay. Make sure you know when to use what formula. So like, is it a t-test? Is it a z-test? Whatever. So I'm going to stop sharing, stop recording.